Hi, welcome all. Welcome on Jim's Orbit. So we have completed part 1 and part 2 of real number, and we have covered the SCF and LCM finding methods. It was very basic procedures we have followed, and we have seen the methods to find the SCF and the LCM of two numbers or more than two numbers. Now today we are going to do the same thing, but we are going to use Euclid's division lemma and Euclid's division algorithm to find the SCF of the numbers and how we should write it in the exam. Okay, this is with the exam point of view, with the CBSE exam point of view. Fine. Let us do a quick revision of what we have covered so far. Okay. So these are some few questions I have taken so that we can just revise those concepts dealt in the video 1 and video 2. Okay. Now, question 1 is, what is the SCF of the smallest composite number and the smallest prime number? Remember, composite number was the number which was having more than two factors. So this can be like 4, 6, 8, 9, 10, correct? But they have asked us the smallest number, and hence this will be 4. Now the smallest prime number. We know prime number is that number which has exactly two factors. Now the smallest is 2. One is neither prime nor composite, so it will never be in either of these. So it will be smallest prime number will be 2. Now they have asked us to find this SCF. Now it is very easy. So SCF of 2, 4 we have to find. We can directly say it is 2. Highest number which can divide both of these is 2 only. Okay. Because 2 divided it's completely. So the SCF is 2. Okay, simple question. This is just 1 marks question. Now let us take the second question. Find the LCM of 2 square into 3 square and 2 square into 3 cube. Okay, this is very simple. Consider A is 2 square with 3 square and B is 2 square into 3 cube. Now obviously you can say this is 2 into 2 2 times and 3 into 3 2 times. Similarly, this is 2 into 2 2 times and 3 into 3 into 3. I hope you remember we have said that we are going to take this which is common in every single number. We have to count it just one time. So our LCM in this will be 2 multiplied by 2 multiplied by 3 multiplied by 3, and this 3 is left behind. So in LCM we take, in SCF we never take. If the question was SCF, we have only taken the circled ones. Okay, so this is 4, this is 3 3 9 3 27, so it is 27 into 4. Okay, 108. Now remember that this was one of the ways. We could have done it some other way, like this. We could have said that if it is 2 square and 2 square, it will be the highest power that will be common. So the LCM could have been directly 2 square multiplied by, now 3 highest power. You see this is 3 times, so highest power will always come out, 3 3. In LCM we take the highest powers. If it was HCF, we take the smallest powers. So it will be 2 2, because obviously there is no other smaller than 2 to the power 2, and 3 to the power 2 would have been the SCF. This is the difference. This is how easily you can just check. Okay, these are some different kind of problems, so just wait. This is a practice problem. Let us take the question number 3 now. Show that the numbers this and this are not co-prime. Again, this was we have already studied about. These co-prime numbers are the numbers which has SCF 1, or in other words, those numbers which have only 1 as their factor. There is no other common factor other than 1. Okay, these are called the co-prime numbers, but we have to prove not co-prime. This is co-prime. Okay, for co-prime we have definition that SCF is 1. Let us check whether the SCF of these two numbers comes 1 or not. Okay, so consider this 231 and 396. I hope you remember. If you have not seen the part 1 and part 2 of the series, please do watch this. Okay, so this is 1 times 231. This is 5. This is 6. This is 1. Now this obviously is 231, which is very very large, because 150, if it is 150, 2 times is 300. So obviously this is more than 231. So we will take only 1 times. Okay, this is 6 and this is 12 minus 6 is 6. Okay, now we take 165. Okay, this here will go 2 times. So 2 6 12, 2 6 12 and 1 13. This will give us 3 and 3. Fine, this is easy now. 2 times. Okay, so you remember this was our answer, the SCF. So SCF is 33. I hope we see that the SCF in this is not 1. Hence, the numbers are not congruent. Since SCF is not equal to 1, this implies the numbers are not congruent. I'm writing in short, you should write numbers, okay? We have congruent. Okay. Let us take the next problem. Question 4. If A and B are two positive integers such that the least prime factor of A is 3, okay, the least prime factor. It means that A does not have any prime number less than 3 as its factor. So it does not has 2 in it. And the least prime factor of B is 5. Okay, so the B has least prime factor as 5, so it does not has 2 or 3 in it. Now calculate the least prime factor of A plus B. It's a very, very good question. You just see how easy it is. If you're saying that A is having 3 as its the least factor, it is some 3k kind of number where it will not have any multiple of 2 in it. You know that if a number does not have a multiple of 2 or it does not have a factor of 2, it obviously means that number is odd. Because there is no 2. There is no 2. It's not number, okay? It's no 2. There is no 2. So it is odd. And for the B, if suppose it is 5 times any number, m, integer or whatever, yeah. This is also odd because in this also we will not have 2 as the prime factor. The least prime factor is 5. Okay. So this is also odd. Hence, if we find A plus B, actually we are going to add odd plus odd. And we know odd plus odd is, what is odd plus odd? It is even. Correct? So, the A plus B is always even. Odd plus odd is even. You see 3 plus 50. It is 80. Yeah, even. Okay. You can check on your own. Okay. So this is even, and we know even is whatever is even, it is 2 times a number, say n. Hence, the least prime factor, of A plus B is 2. Okay, this is a tricky question, but it's simple. It's not that much tricky. Okay, we start with the theorem now. So that was the revision part. Euclid's division lemma. It says that if you have positive integers A and B, that they can never be negative. Remember this thing also. And there exist unique integers Q and R. What they are, I will explain it in just a few seconds later. Satisfying A is equal to BQ plus R, then R should be between 0 to B. Now let us try to understand this. It is saying that, consider this. A is the dividend. Okay. B is the divisor. Your Q is the quotient and your R is the remainder. Now, we have done this kind of things in our junior classes. How we were doing it? Suppose we are taking 3 and we are going to divide 22. We should have written 3 7 times 21. It will give us 1 as our remainder. Correct. We knew that 22 can be written as the dividend can be written as divisor into quotient plus remainder. That is correct. Yeah. So if we are going to divide A by a number B and you are getting Q as the quotient, your remainder is R, then obviously this A is equal to BQ, divisor into quotient, plus the remainder. Correct? Now, the thing is, what is this saying to us? What is this condition? To understand this, let us take this problem and exploit it further. Okay, let us just dig it down. So we have this. Suppose I take 3 and I take a number 21. If we divide it, we get 3 7s are 21. We get remainder 0. Now consider this is 22. So 3 7s are 21. You have this 1. Now consider 23. 3 7s are 21. You have 2. Now again consider 24. We have 3 8s are 24. And this is 0. You notice that your remainder just moved from 0, 1, 2 and again became 0. It never became 3 nor it became 4 or whatever. Obviously, if it is getting 3, you are dividing something and you are getting this 3. Suppose something is written and you are written and you got 3. Is it not further divisible? 3 1 times. 3 1 times 3. Yeah. So how can you say that your remainder is 3? It is not possible. This is what that was saying in the previous page. Notice, it was saying that remainder should be more than 0 or equal to 0, but it is less than the divisor value. Hence, when we move ahead, when we see this, that 0, 1 and 2, the remainder is always either more than or equal to 0, but it is always less than the divisor value and just one less. So you can say it is less than b, or if you want to just say in other words, you can say it is equal to b minus 1. This is the same thing. 3 minus 1 is 2. So that is why you said that you can only reach till the value 2. Okay, this is very simple. You are going to write this lemma as your A is equal to BQ plus R, where R has the freedom to go from 0 and it has to be less than the divisor value, 1 less than the divisor value. Fine. This is the lemma. But algorithm is actually a set of rules which we follow to get some desired function. Okay, like suppose you want to find the SCF. Now this is an algorithm which can help us to find the SCF. Okay, by applying this lemma again and again, by applying this lemma as a set of rule again and again till we get the remainder 0, we will find the SCF by this algorithm. This is what difference of lemma and algorithm is. Lemma is single rule, and if you apply that rule multiple times with the condition that till you have got R0, that becomes your algorithm. Okay, this is a simple process. Now, to make this easy and understandable, let us take the same number we have taken in the earlier videos, 24 and 60. Okay, what we were doing? We were actually dividing it. 24 and 60. 24 2 times 48. It's 12. Then you copy that down. And 12 2 times 24. And this gives us 0. Correct. So we have got this. Now in lemma form, it will be written like this in your paper. You do this separately on your paper rough sheet like this, or you draw a side column and you complete this. And then in this end, you write by applying by Euclid's division algorithm. Euclid's division, or you can say Euclid's division lemma. It is much more correct. So lemma, by Euclid's division lemma, we have 60, that is the dividend, is equal to divisor 24 multiplied by the quotient 2 plus the remainder. In the first case, the remainder is 12. Again, by Euclid's division lemma, you write, or you keep on writing it. Okay, so you write 24, your new dividend, is equal to 12 multiplied by 2 divisor into quotient plus remainder, and this process stops when the remainder is 0. Hence your SCF is that divisor which just divided it. Okay, so your SCF is 12. The divisor at this stage where you get remainder 0 is the SCF. I hope you have understood this step 1, step 2, step 3 and your simple example. It is very simple. It will never come in your exam. Okay, don't you think that it is going to come anyhow? So we are going to take one typical lengthy. Okay, so let us consider 4052 and 12576 as our two numbers for which we have to apply the Euclid's lemma or the algorithm to get the SCF. Now it is very simple. You write the smaller one here and you make the dividend as your bigger number or the larger number. Now see, I am telling you some tricks to solve it easy. 4 3 times is 12, and this will be 12,000 if it was 0 0 0. Now we know we have to get till 12 only, so 12,000 is fine. But see, notice this, 52 if you multiply by 3, you only get till 150, 156, which is not 576. Hence 3 is easily we can do. 4 if we do, we get 16,000 more to 8,000, very very less. So you have to reach till this point as close as possible. Exactly if you are getting, that's your luck. Okay, otherwise you have to move like this only, closest. So it will be 12 1 15, so 156. Okay, so 0 2 and 4. Now what you have to do, you have to copy paste it and you have to make your new divisor your divisor as your dividend. Okay, now 420 again do the same. Now if you have multiplied by 10, you would have got 4200. It is very, very large. Let us do for 9. 9 4s are 36. It is very less than 40. Very, very less. So 9 will work. So 3780. So 2, 50 minus 8 is 7. 9 minus 7 is 2. Okay. Now we have to copy this 420 as our new dividend. Now again you see it 250. If it was 250, double was 500. So 500 is not this. So 2 times we will not do. We will do only 1 times. So 272. I'm telling you how we are doing it the multiplication rather than actually multiplying. We are getting the exact number we have to write here. Okay. These are very small things. It comes with practice also. So 10 minus 2 is 8. 11 minus 7 is 4. 48. And 3 minus 2 is 148. So let us do the same thing and copy this 272 here. So we get only 1 time. So it's simple now. It's very, very simple. So 12 minus 8 is 4. And 6 minus 4 is 2. 24 is fine. We will not get anything else. So 148 we will do. It will go for like 24. Now see, 24 will be like 5 times 120. And 6 times is 6 to the 24. 6 to the 20. 144. No, it's not 144. It's... How it is? Is it 144? 24 6 times? No. Yeah, it's 144. So... Oh, sorry. It is 6 minus 4 is 2. 2 minus 1 is 1. Okay, now it is 1. So 1 times 1. Sorry, I have not seen that 2 minus 1. So 4, 2. Now you are going to do for 124. 24 5 times is 120. Now it is 5. This is 4. And again 24 you are going to write 6 times 24. You get the remainder 0 at last. I was wondering whether we will reach or not. Fine. So I'm erasing this part. Okay. Now what you have to do, you have to write the SCF using the Euclid's lemma. So I am writing here only. I don't want to change the page and make it confusing for you. So I'm writing by Euclid's lemma, division lemma. I'm writing very fast, so it's just not writing it. Okay? Euclid's division lemma, you understand that? You have to write this dividend and the rules. So you write 1, 2, 5, 7, 6, and you have to write 4052 multiplied by 3 plus your remainder 420. Okay, now keep writing the same things. So you get 4052. You have to copy this dividend, this into this plus this. Direct, easy. Now I can move ahead. It's very easy. So this 420, 272 into 1 plus this. See how easy it is now. Once you have done this, now this into this will be 272. So 272 is what it 148 multiplied by 1 plus 124. Now for 148 we will have 124 multiplied by 1 plus 24. Now for 124 it will be 24 multiplied by 5 plus 4. Now for 24 it will be 4 multiplied by 6 plus 0. Now you notice you got the 0, and the rule says once you get the remainder 0, your current divisor, that last stage divisor, is your SCF. So your SCF is, I'm writing here, so your SCF is 4. This is the answer we have to complete. I hope you have understood this. Okay, so I took one bigger number and hence I have completed that way. Okay, what will happen if you have this 3 numbers? Oh my god. Okay, fine, I'll try to adjust it. Okay, this says that you have got 3 big numbers and you have to apply the Euclid's division algorithm. Okay, I'll tell you one very special rule to simplify it. Take these 2 smaller ones and solve this, because then you will get the answer very easily, and they're very close to also, so you will obviously get them very easily. And once you get this, use that SCF to simplify with this. So these are always solved in pair. You cannot solve all 3 of them at once. So you have to find the SCF in 2 stages. So I'm moving with the first stage. So I'm writing 7378. Okay, I have to divide this by 7161. So rather than, I'm just erasing. So it will be 7161 and 7378. It is easy. It will be only one times 7161. You will get 7. 7 minus 6 is 1. 3 minus 1 is 2. So 217 you get. 7161. Now you don't have to write like 2171 is going sometime, then some will be left out. We copy that down. We never do this in SCF. We have to reach at the highest. If you can read 12 times, 13 times, it's okay. So rather than doing that way, you do a rough sheet. You solve this separately. So 1 times 3 times it will go, because 3 2s are 6, so 600 something will come. 4 2s are 8, so we are not want 800 something. So 3 times 3 7 is 21, 51 is this, 17 3s are 51, and 651 is this. So 5, 11 minus 5 is 6. Okay, and again 651. Great. So this is 33. How easily we have got this. Okay. So again it was 651, so 33 only. So 33 times it will just completely divide it. It's great. So we have got 217 as our first SCF. This is our first SCF. Now we have to use this and this bigger one as our next step. So I'm going to erase this. This is what I've done. Okay, I'm going to write here only. I don't want to change the page. The whole thing I'm not doing is I don't want to change the page and make it confusing. Okay, so I'm going to write 217 and I'm going to use this with my 92690. Let us do this. Again, we have to get this 217 as the max at most we have to reach. Now, how we will do this? We will have to multiply and do it separately. So 217 and 92690. Okay, I'll do it on this next page and then I'll come back rather than erasing every time. So 217 and 92690. So it will have 4 times will do. 4 2s are 8 is fine. So 4 times will do. 4 17s are 68 and 4 2s are 8. So it was fine. 16 minus 8 is 8. 11 minus 6 is 5. Okay, it's gone. So it will be 9 copied. So 589, it's 3 times is 600. So we will only do 2 times. So 2 17s are 34 and 2 2s are 4. Now 5, 5 and 1. Okay, 0 will copy down. Now 217, 7 2s is 14 and 8 2s are 16. So 7 times will work. So 7 times, 7 7s are 49, 9, 4, 7 is 7 or 4, 11, 1, 1, 7 2s are 14 plus 1, 15. Okay, so 10 minus 9 is 1. And 4 minus 1 is 3. So we get 31. Okay. Now what we have to do, we have to just multiply these and directly write here. I'm telling you where. Here. You have to directly write this. So you have to write 217 exactly 427 times. Now the problem is, how will you write 427? Will you multiply these two numbers? No. I'm telling you one special way of doing it. Listen carefully. What you do, you write 420 and 7. Is it not correct? 420 and 7. Okay, so now you just multiply 217 into 4. Okay, I'm changing the page. Sorry for this. I'm changing the page. I'm writing here. So it is 420 and 7. Okay, you have done this. You can write 427 as this. So 217 fours are, you already have done this. 868. And 00, copy it. 217 twos are already done that. 434 plus 10 is extra there. So 4340. And then in the end, 217 sevens are 1519. How easily we have got. We have not multiplied it again. I hope you understand. This is one method. You can save your 1 minute or 2 minutes. Okay. Okay, fine. Let us do this. So 9, 5, 8, 8, 16, 6, 1, 7, 1, 8, 4, 12, 2, 1, and 9. So it is 9, 2, 6, 5, 9. See, if you subtract 90 and 59, you will get this only. 31. Correct. So 92659. Let us come back. 92659. See how easily we got this. And minus. Subtract this, you get 1, and 8 minus 5 is 3. 13. Okay. Now copy this 217. 31 7. 7 is 7. 7 3 is 21. I hope you understand this. And I'm telling you, if you have taken these two as your first pair, you would have completed this page and the next page. And I have done that. And that's why I'm telling you. And then I saw, okay, I've done this mistake. I should have taken the smaller ones. So please do follow this. Take the two smaller ones and then which are nearer to each other. That is the smaller ones I mean. Okay. And the bigger one, keep that separate. Let it rest for some time. Yeah. Okay. So leave it aside and do the smaller ones. Whatever you get, use that with the bigger one and then you will. This is the trick I have told you in the next page. Okay. So how will you write this? Extremely easy. You start with the first one with the lemma. So 7378 will be like 7161 multiplied by 1 plus 217. Then you copy this 7161. Your 217 is your new divisor, multiplied by 33 and 0 is the remainder. It is the SCF in the first case, but that is not our answer. So you continue with this 92690 and divided by 217 multiplied by 427 plus 31 is your remainder. Then take 217 and divide it by 31, you get 7 plus 0. This is your final answer. So your SCF is 30. This is your answer. Please do understand, this is a very important question. If it comes in 4 numbers, this is the question of 4 number. This is not a question of 3 numbers. Okay, it takes time and it also requires a lot of tricks, a lot of mind usage. Okay, so you have to understand this. So I'm stopping here, and what we will do next, we will take one category that is given in addition only. When you have to represent SCF in some A into M plus B into N form. Yeah, and that is quite tricky. Sometimes they can give you in 2 marks, but not directly. So if you move ahead, we will do the word problem also. Otherwise, we will do the word problem in the later part of the videos. Okay, I hope you have understood this, and thanks for watching. And one more thing, please do if you do not like the video, what I'm trying to do, just push the dislike button. Okay, press the dislike button, and in the comments, please let me know what is the thing I should do to improve it. Okay, so that will help me a lot in improving this part. And if you don't press the dislike button, I will also not know that how much of the people are not liking it. Okay, so please do that and let me know my weaknesses so I can improve. And I hope you like the videos, so keep sharing them, okay, with your friends. And thanks for watching. We'll meet in the next video. Thanks again. Bye.